In this video, we are going to learn about solution chemistry and colligative properties. Solutions can be measured in concentration, and concentration is a measure of the amount of solute dissolved in a given quantity of solvent. So in these examples, we have two beakers. In this first beaker, as you can see, the number of solutes, which is in blue, is much higher than the number of solvent particles, which is in purple. And quantitatively, we can tell it's a darker solution, more concentrated solution than the one on the right, which is more dilute. We can measure concentration quantitatively by using a unit called molarity, and molarity is moles of solute per liters of solvent. So an example would be a 1 molar salt water solution is a mole of salt dissolved in 1 liter of water. In the lab, if I asked you to make up a 1 molar salt solution, you would have to get a scale, which measures in grams, and convert 1 mole, 2 grams, so that you could measure it quantitatively. And to do that, you would just add 25 grams plus 35.45 grams to make 58.45 grams of sodium chloride, which would make up 1 mole of sodium chloride. We could also work out other problems. Another example would be, what is the molarity of a salt solution if you have 25 grams of salt in 750 milliliters of water? You would first convert from grams to moles, so 25 grams times the molar mass of sodium chloride on the bottom and 1 mole on the top, and that's 0.42 moles of sodium chloride. And then you would also have to convert from milliliters to liters just by moving the decimal 3 places to the left, so that's 0.75 liters. And molarity is mole per liter, so you just plug in 0.42 moles over 0.750 liters, and it's a 0.56 molar salt solution. Colligative properties are properties of solutions that depend on the number of particles present. They include vapor pressure, boiling point elevation, and freezing point depression. If you were to take pure water and heat it up, water would boil or evaporate, and the pressure at which that gas exerts on the container is called vapor pressure. So if you were to add solute, then you would find that the solute particles block the surface and fewer solvent molecules can escape. And so it would be have a lowering of the vapor pressure effect. So in sum, vapor pressure decreases with the addition of solute. With boiling point, boiling point is a temperature where vapor pressure equals the atmospheric pressure. So with pure water, we know that the boiling point is 100 degrees. If we add a solute, such as salt, then the boiling point is going to be greater than 100 degrees. The vapor pressure decreases, and it takes more energy to raise the boiling point temperature, so the boiling point increases. So it's harder for those molecules to escape into the gas phase. That's called boiling point elevation. Freezing point is the addition of solute, which actually has an opposite effect. It lowers the point at which water freezes or the solvent freezes. So freezing point for regular, just plain pure water is 0 degrees Celsius. The freezing point of salt water, the salt actually blocks the hydrogen bonds between the water molecules, and it actually needs to freeze at a lower temperature, and that's called freezing point depression. So in sum, with solutes, you have a lowering of vapor pressure, lowering of freezing point, and boiling point elevation. The more particles that are added, the more that these change. So the number of particles added depends on whether or not you have ionic or covalent bonds. So let us consider the following: a 0.1 molar calcium chloride solution, a 0.1 molar lithium fluoride solution, a 0.1 molar calcium nitride solution. Which of these is going to have a higher boiling point? Well, we have to count the number of particles. So calcium chloride has 1 calcium and 2 chlorine, so that's 3 particles. Lithium fluoride has 2 particles, and calcium nitride has 3 calcium, 2 nitrogen, so that's 5 particles. So they all have the same number of moles per liter, but so we can compare them just in terms of particles. So because calcium, if we wanted to know which has the highest boiling point, because calcium nitride has more particles, those particles are going to block the water from escaping, so you're going to have to put more energy in to get that water to boil, and you're going to have a higher boiling point. If we wanted to know which has the lowest vapor pressure, again, calcium nitride would, because there are more particles, and so it's harder for those molecules to escape, and so there's going to be less vapor, and therefore less vapor putting force on the container, or per unit area. Which has the highest freezing point? So the highest freezing point is going to be the one with the least amount of particles, and that's because of freezing point depression. So freezing point decreases with the number of particles. So the highest freezing point is going to be the one with the least number of particles. And the one with the most number of particles is going to have the lowest freezing point, which is calcium nitride. Now, covalent molecules do not dissociate in water. So if we were to compare these three with a 0.1 molar glucose solution, then we would find that glucose would only have 1 particle, C6H12O6, that does not dissociate. So you're going to treat ionic compounds, i.e. metals and nonmetals, differently than covalent. Covalent compounds only make 1 particle versus ionic.